Hey everybody, we are in the next lesson, 9-6, in the Tennessee Revealed Geometry, applying trigonometry. Now, word problems. That's what this is. But it's still the same stuff from trigonometry. Your sine, cosine, tangent, your Oscar had a heap of apples. They're just going to do it as word problems. All right. You're going to see two different types of meanings: angle of elevation, angle of depression. Now, the secret thing is they really kind of are the same number. So I usually tell my students, if you're a brand new teacher, I usually tell my students that it's the angle at the bottom that meets the ground is really your angle that you want to kind of look at, because some of these problems can be kind of tricky. So if you're not understanding what I'm talking about, let's get into it. And I'm sure you're going to probably see an example of one of those. Okay, so we're on page 541 of your workbook. So grab that book, turn it to page 541. All right, you're going to see, looks like some definitions. All right, so often the only way to measure an object is through the use of indirect measurement, which involves looking at similar things. So you're not going to say, hey, look, this segment is blah, 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 because you can measure it. All right, angle of elevation, angle of depression, like I said, is kind of the same thing. They're alternate interior angles. So they're equal to each other. They're going to be the same number. So a lot of times my students will get bogged down in which one it is. Well, Miss Eccles, how do I know? Blah, 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 blah. Well, if you give you the angle of depression, which is outside of the triangle that you're referring to, just switch it over to its alternate interior angle, which is the angle of elevation, and boom, you've got the angle that you need. Same answer. Now, it may switch up which one you use, sine, cosine, maybe tangent, maybe not, but it's going to be the same number. All right, so let's get into example number 1, bottom of page 541. All right, it says Rakeem is flying his drone at the park. He spots the drone at an angle of elevation. This is the angle right there, looking up. So that's kind of like your bottom where your ground level is. All right, the remote control tells Rakeem that his drone is 102 feet above the ground. All right, there you go. That's from his feet, by the way. If Rakeem is 6 feet tall, so the distance from C to the bottom of the ground is 6. All right, so right there is 6. So basically, if you want the height of the triangle, you're going to take 102, subtract 6, and that's going to be the distance from B to C. I guarantee that's probably not how they're going to work it, though. All right, how far is he from the drone of the nearest foot? So looking for this distance along the ground. This length. That's going to be, let me reread that again. Represent the distance from, oh no, they want the distance from A to B. I read that wrong. My apologies. They want where his head is to the drone itself. That's your hypotenuse. That is your hypotenuse of the triangle. Okay, so grab your calculator. Make sure it's in degrees, because you're definitely going to have your calculator in degrees, simply because if it's not, you're going to get the wrong answers. All right, so here we go. All right, so first off, they are going to do it like I said. Okay, so they're going to subtract 102 and his height 6 feet to get BC, which is the height of the triangle from B to C. So that's going to give you 102 minus 6 is 96. All right, so this is a sine problem, since the 30-degree angle of elevation is the only acute angle you have. We have the opposite side, which is the 96, and we're looking for the hypotenuse, which is your unknown, AB. All right, so let's see. That's going to be sine of the theta, A, is opposite over the hypotenuse. So they're going to replace the theta with 30. They're going to replace the opposite side with the 96, and again, because that's 102 minus his 6 feet is 96, and then divided by your hypotenuse, which is your unknown x. All right. Looks like they're going to do a shortcut. Good. I teach my students this same way. If x is on the bottom, take these two things and switch their places, because you can't take a 96 and divide by x in a calculator, but you can take a 96 and divide by the sine of 30 in a calculator. So switch their places, grab you a calculator, make sure it's in degrees, put in 96 divided by the sine of 30 degrees. And it looks like you're going to get 192 feet. So Rakeem is 192 feet from his drone. Okay. Looks like that's all you need for example number 1. So there's a check on the next page. So everybody turn to the next page. Let's look at a check. A flare is shot vertically into the air approximately 200 feet from the base camp. That is straight up. That is going to be the height of the triangle. Straight up. The angle of elevation from the base of the camp to the maximum height is 35 degrees. All right, so if you're a visual person, I'm talking about this right there is 35. And the height is 200. Okay. The group at the base camp needs to know the altitude of the flare. All right. Write an equation that represents the situation if A represents the height of the flare. Okay. Well, first off, I'm confused because this set it says it's shot vertically. Vertically to me and pretty much any math teacher, geometry anyway, it's going to be straight up in the air, which is 200. And then they're asking for the height. Well, the height would be 200. Okay, well, okay, so interesting. Well, being that it is a 35-degree angle, you visual people, let me show you what it's asking, because I got a little confused here too. So if we have a right triangle, something that looks like this, they're saying this is your 200. This right here is your 200. It is shot up in the air, 200. This right here is your theta. That's going to be your 35 degrees. And I have no idea if this is drawn correctly or not, but it's here to give you my visual people, something to look at. They want to know the height. That's going to be what the triangle looks like. So I got a little confused when it said shot vertically. Vertically means to me up, straight up, 200 feet straight up. But because it says it's shot 35 degrees, it's shot vertically out. Not really vertically. It's just shot up 200 feet at an angle of 35 degrees. All right, so that was a little confusing. All right, so which means that we are looking at your theta 35. Your opposite is the unknown that you're looking for, and the hypotenuse, because this is your right angle, is 200. So it's going to be a sine problem. Sine of 35 equals opposite x over the hypotenuse 200. All right, so let's go back. Sine 35 degrees equals, and I need a fraction, x over 200. So there is going to be your equation. All right, what's the maximum height? Okay, so here's what we're going to solve it. The opposite of dividing by 200 is to multiply by 200. So you're going to take 200 multiplied by the sine of 35. And that's going to be approximately, to the nearest meter, 115. And the reason why is because the 7 that is after the decimal point in the tenths place makes the 4 go up, round up to a 5. To the nearest meter is 115 meters. 115 meters. Okay, so that's a little confusing. So you guys are going to pay attention to the wording. Straight up vertically would be straight up at 90 degrees, and this is shooting out at 35. All right. Example number 2. Okay, we are on the next page, page 542 in your workbook. All right, Cottonwood, Idaho's Dog Bark Park Inn is a popular tourist attraction featuring a hotel in the shape of a 30-foot wood carved beagle. I really want to go see that. Pedro looks out the window 30 feet from the ground and spots a fire hydrant on the ground at an estimated angle of depression of 40 degrees, which means your angle of elevation right here is 40 degrees. What is the horizontal distance from Pedro to the hydrant to the nearest foot? Okay. All right, so let's see here. Let's see. So these are parallel, is what this problem is saying. And what that means that if this angle is 40 degrees, angle BAC, ACD is 40 degrees. Good. I love that they changed it over to an angle of elevation because that makes your problem quite easier. So this is the angle of elevation, which is 40. Alternate interior angles are equal. And I did say that at the beginning of the lesson, so I'm very happy they're doing that. All right, so we are looking at C being our theta, 40 degrees. We have the opposite side, 30, to angle C, and we are looking for the adjacent side, which is your unknown X. Well, anytime you have an angle where you have the opposite and you're finding the adjacent, this is a tangent problem. So let X represent the, I guess, CD distance or DC distance from the base to the hotel to the hydrant. All right, so it's going to be a tangent. We're going to put in 40 for the theta, or angle C. Your opposite side is 30. Your adjacent side is X. All right, we are multiply each side by X. Okay, so they're not flip-flopping them. They're making me show the actual steps and then divide by the tangent of 40. So switch their places is what they're doing. They're just showing that one step in between. All right, so 30 divided by the tangent of 40 is, and what do they want me to round it to? The nearest foot. So that's going to be approximately 35.7. So the nearest foot would be 36 feet. Because a 7 makes the 5 go to a 6. 36 feet, everybody. All right, you just found the distance from C to D, which is the distance from Pedro to the hydrant. All right, got to check right here. And they do not give me anything to look at. Oh, lovely. All right. Braylon stands on an 8-foot platform and sights a swimmer at an angle of depression of 5 degrees. If Braylon is 6 feet tall, how far away is the swimmer from the base of the platform to the nearest foot? Okay, guys, hang on a second. I got somebody coming in my door. Give me just a second. Oh, okay, sorry about that, you guys. All right, so back to it. Let's see here. Braylon's on an 8-foot platform, sights a swimmer angle of depression of 5 degrees. Braylon is 6 feet tall. How far was the swimmer from the base of the platform, the nearest foot? Okay, I know most of you guys are visual people, so let me give you guys something to look at. Okay, so dude is standing on a platform. Okay, let's see if I can draw this. All right, so dude standing on some kind of platform. All right, you got a dude standing right here. All right, this is going to be my guy. Woohoo! Yeah, his hand's coming out of his neck. Y'all get to laugh at me for a minute. All right, there's my dude. Okay. All right, he is. Let me see this one more time. Standing on an 8-foot platform, so this is going to be 8 feet. No, it doesn't look like it, but stay with me. He's 8 feet. All right, the platform's 8 feet. Dude is 6 feet tall. So dude is 6 feet tall. So that's actually going to be 14 feet total. 14 feet from the water up to him. That is actually going to be the height of the triangle. Because here you go, visual people. Let me draw you the triangle. Oops, get back there. That's what I wanted right there. Really? I want a polygon. Okay, here we go. All right. So the 14 is your height of this right triangle. All right. It says, what's it say next? 5 degrees, angle depression. Well, the angle depression technically is right here, but for our purposes, we are going to put it where it's easier. There it is. There's your 5 degrees. All right. And they want to know how far the swimmer is out. That's going to be your X right there. All right, visual people. There it is. This is your theta. Whoop. This is your opposite side, 14. And again, that's the 8-foot platform plus his 6 feet in height. And we are looking for the adjacent side to the theta. All right, that's going to be your X. So this is a tangent problem. Tangent is opposite over the adjacent. So it's going to be tangent of 5 equals, and it doesn't give me any room on the other page to do this, so I'll just do it right here. Tangent 5 degrees equals opposite 14 over the adjacent X. And you can't take a 14 and divide by the X in a calculator, so you're going to switch their places. And you're going to take 14 and divide by the tangent of 5. So everybody grab a calculator, put in 14. Hit divided by. Got a tangent. Put in 5 degrees. And you should be looking at 160. All right, so it looks like this is 160 feet. All right, kind of a trick little question right there. Got to watch how that height plays into the problem. All right, example number 3, moving on. Okay, next page of your workbook, page 543. All right, use 2 angles of elevation and depression. All right, Way is estimating the height of the 2nd floor in the mall. Oh, hang on, you guys. I got another person coming in. Hang on just a second. I'll be right back. Okay, I'm back. Sorry about that, you guys. It's like Grand Central Station sometimes around here. Okay, where was I? All right, Way is estimating the height of a 2nd floor in the mall. She sights the 2nd floor at 10-degree angle of elevation. There it is. Then she steps forward 50 feet. Boop, 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 boop. Okay, until she is 5.5 feet from the wall. Okay, so she's standing right here where C is, because that would be within 5.5 from the wall. All right, she sights the 2nd floor again. If Way's line of sight is 66 inches above the ground, that's right there. That's what they're talking about. What is the angle of elevation? All right, at what angle of elevation? So they're looking for Y. That's what they're looking for. They want angle Y right there. Okay, well, let's end this triangle, ABC. And the only side I had of is 5.5. So, okay, so it looks like I've got to find another side of triangle ABC, which is going to be X, I would think, in order to use trigonometry to find the angle Y, which is the angle of elevation. All right, so here's the thing. I'm going to have to do 2 trig problems. The first one for the big triangle, ABD, to find AB side, which is your opposite to where Way is standing at the beginning before she walks forward. Then once I find this AB, I'm going to get her to walk forward, get her to right here, and I can use the opposite and the adjacent side to find angle Y, which is our angle of elevation. Okay, goodness. All right, so we got 2 trigs in this one particular example, everybody. All right, here we go. All right. Oh, they set it up for me. I love it. All right. So Way standing out here. She's looking up 10 degrees. We need the opposite side to Way. And if we add these 2 lengths together, we'll have how far she is from the wall, which is going to be 50 plus 5.5. That's going to be 55.5. And it looks like they go ahead and add that for me, which is nice. Man, they set the whole thing up. Okay. So opposite X over the adjacent 55.5 is a tangent problem. And the opposite of dividing by 55.5 is to multiply to the other side by 55.5. So everybody grab your calculator, put in 55.5 times the tangent of 10 degrees. And you're looking at approximately 9 point, 786. It keeps going on and on and on. You know what? I'm not going to round that in the middle of the problem, because I have found in the past if I round something in the middle of a problem, my final answer ends up coming a little off. So I'm going to keep it 9.786, blah, 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 blah. Okay, so Way's going to step up. Now she is only 5.5 feet away from the, looks like the wall. And I still need my angle of elevation here, but now I have the height. So it's going to be a tangent problem because I have my opposite. That's that 9.786 you just found. And I have my adjacent 5.5. And I'm going to be using inverse because I'm looking for the angle. So it's going to be tangent of y. And for AB, we should put in the 9.786 on top and divide by the 5.5. All right, I'm not sure why they didn't do that, but okay, we're going to go with it. Everybody get your calculator and do inverse tangent. That is your tangent to the -1. So depending on what kind of calculator you have as to what you do. I have a green second button, and then I'm going to hit tangent, which pulls up my inverse tangent. Some of you may have a yellow shift key before you hit tangent to pull up your inverse tangent. Some of you may have an Inspire calculator, which means you go to your trig function button and select tangent to the -1 power. I don't know what you're going to do because I don't know what calculator you've got. But anyway, go to the tangent to the -1, put in your 9.7 answer, 9.786, divide by 5.5, and hit enter. You should be looking at approximately 60.66. Now they want us to round that. Usually it would tell us. Okay, here we go. Okay, they did it in a whole problem. So, well, there you go. Approximately 60.66. I didn't realize it was a third section there. Okay, so, yeah. 60.66 is basically 61 degrees, approximately. All right, so that's where you put your 9.786. All right, it's about 60. I guess they want 61 degrees, I'm guessing. All right, so there you go. Okay, we got a check here. All right. Goodness, we have this being really long. Oh, we got area coming up. Okay. Because I see that 1/2 AB going. All right, so let's go. All right, sightseeing. I'm on the bottom of page 542 of your workbook. We're looking at a check. Look north. 2 skyscrapers are sighted from the viewing deck of an Empire State Building, which is at the height of 1,250 feet. The base of the skyscraper is sighted 20 degrees angle of depression. Remember, that's the same thing as angle of elevation. And the base of the second is the sighted 30 degrees. All right. How far apart are the 2 skyscrapers? All right. Hang on a second. Let me draw this out for you guys. I'm going to stop the video just for a second so I can draw it out. And let me get back to you so you're not taking up a lot of your time. So just hang tight for a second. Let me pause this. All right, you guys got it drawn out. A little bit more complicated than what I thought. Okay, so there we go. We've got a skyscraper, 1,250 feet tall. Looking down, angle of depression. Remember the same thing as angle of elevation. So I got 2 triangles here. I got a 30-degree triangle, BFC, with the same height as the triangle, the 20-degree angle, BEC, and that's a 20-degree. All right, so you're looking at 2 different tangent problems. And the reason why is because the problem is asking for how far apart are these buildings. Okay, so we're looking at a tangent with a 30-degree. The opposite is 1250, and we need to find the x, which is the bottom. And we have a tangent problem where the theta is 20 degrees. Your opposite is 1250, and we need to find the base, which is your adjacent side. Find those 2, and we're going to subtract them to see how far apart they are to each other. All right. See if I can do this any justice at all. All right, so we got tangent. Make my life a little easier. We're going to do 30 degrees is equal to opposite. And that's going to be your 1250. All right, divided by your adjacent x. All right, well, we can't take 1250 and divide by x. So we're going to take 1250, switch their places, divide by the tangent of 30. So 1250 divided by tangent 30. All right, so you should be looking at 2,165 0.06-ish. That's an approximation. All right, next triangle. Tangent of 20 degrees. This is your theta. Is equal to your opposite. 1,250. Woo! Ugly 50. Divided by your x unknown. Well, I can't take 1250 and divide by x, so I'm going to take it x and switch it with the tangent of 20. So 1,250 divided by the tangent of 20. 3,434.346-ish. All right, so there's the height of the distance, excuse me, and of each of them, and now we're going to subtract them to see how far apart they are. So take those two numbers. Let's see if I can grab my calculator. Subtract that one. Come on, calculator. Don't fail me now. All right, so when I subtract them, I got 1,269.28. And it says round to the nearest foot. So that will be 1,269 feet, because the 0.2 does not make the 9 go up. All right, there it is. 1,269. Ooh, I am running out of time. Okay, so now we're finding area of a triangle. Area for a triangle is 1/2 base times height. But because these are probably not going to be right triangles. Yeah, they're not. Look at that. All right, so we got a formula to use for the trig. 1/2 AB. Those little letters means those are your sides. Sine of C, the big letter means that's your angle. Actually, these are not hard at all. They really just plug and chug, which is super nice. So 1/2, my two sides are the 11.1 and the 14.1. Sine of C, big letter, is an angle. That's 47 degrees. Grab a calculator. Type all of this in. 1/2 times 11.1 times 14.1 times the sine of 47 is about 57. The nearest tenth is 0.2. All right, same thing here. All right, we're going to put in 1/2. So everybody grab a calculator, put in 1/2 times 20.5 times 22.7 times, everybody hit your sine button, put in the angle, 47 degrees. Hit enter, and it is to the nearest tenth, approximately 170.2, because the 6 makes the 1 go to a 2. All right, what do we got here? All right, we're going to find the area. Find the area of the triangle. Okay. Oh, it's a trick question. They don't give me the angle I need between them. All right, well, y'all, what do 3 angles of a triangle add up to be? All right, yes, that's right, 180. So I'm going to take 180, subtract 34, subtract 58 to give me the angle that I need. So 180 minus 34 minus 58 is an 88-degree angle. And, all right, so that means angle F is going to be 88 degrees. Now I'm ready to plug in 1/2 of 6.7 times 5.7 times the sine of 88. All right, grab your calculator. 0.5 times 6.7 times 5.7 times sine 88 is approximately 19. 0.08336. All right, then when we round to the nearest tenth, it'll be 19.1. All right, running out of time there at the end because my classes are about to come in. Oh, y'all, do this on yourself. Do the same thing. 180 minus 83 and 35 gets you angle K. And then put in 1/2 times 6 times 10.5 times the sine of whatever you get when you subtract 180 minus 83 minus 35. And if I did it right, super fast, 27.8. I am not sure if that's right, but it should be 62 degrees. So 1/2 times 6 times 10.5 times the sine of 62 degrees. Darn, I did right. Oh, okay. They're doing announcements. I gotta go.